Hi all, I'm Thanu James, Assistant Professor EEE, KCG College of Technology, Chennai. Now through my video presentation, I would be dealing the introduction of microcontroller. Now moving into the contents of my presentation includes history of the microprocessor and microcontroller, difference between microprocessor and microcontroller, and to the end we have the applications of microprocessor and microcontroller. Now before starting what a microcontroller is, we would just see what a microprocessor is all about. So microprocessor is nothing but a CPU. Now what does a CPU do? It will take in data, it will process the data and then gives out a output. Now microprocessor is nothing but the CPU. Now in the same way microprocessor, it will take in the digital data and will process the data and then gives out the result as an output based upon the instructions stored in their memory. Now moving into the block diagram of a microprocessor, we have the microprocessor which is nothing but the CPU, and it is attached or it is add on with the features of RAM, ROM, input outputs, timers and serial COM ports, etc. Now your CPU or the microprocessor cannot work alone. It needs all these peripherals attached to it to perform a task. Now moving into the microcontroller, it is nothing but an integrated chip which can perform specific task. And microcontrollers are nothing but a computer on a chip. So the things what we have seen in the block diagram of a microprocessor, all those units will be integrated on a single chip. So whereas in the CPU, RAM, ROM, input output, timers and serial COM ports are all integrated on a single chip. Now we have seen what a microprocessor and microcontroller is. We would just differentiate these microprocessor and microcontrollers. Now as I said, microprocessors are done for general purpose functions or general purpose task. But moving into the microcontroller, they does specific task. And from the block diagram, you can see that your CPU, the peripherals will be attached to the CPU. So the system as a whole comes as a bulkier unit. But microcontroller, as you see, all the units or all the peripherals plus the CPU will be on a single chip and therefore makes your microcontroller lesser in size. And since it is lesser in size, the cost will also diminish. Now the main advantage of a microprocessor is that its processing time is in gigahertz, whereas in a microcontroller it's in megahertz. Now a much more advantage of using a microprocessor is that it is more versatile. That is, you can add on memory to it for a microprocessor. But for a microcontroller, it is lesser versatile because the chip will be integrated with the ROM and a RAM and you cannot add on memories to the microcontroller. Now moving into the applications of microcontroller, fridge, washing machine, ovens, printers are all examples of a microcontroller, and as you see, they are all doing specific tasks as such. Now moving into the history and development of these microcontrollers, it started off with vacuum tubes in 1939 and then introduction of transistors, and these transistors are integrated to form an integrated chip in 1960s, and these integrated chips made into the formation of microcontroller and microprocessor in 1971. Now moving into the history of microcontrollers, we have the first microprocessor which was discovered by Intel, and it was a 4-bit microprocessor which were produced to be integrated with calculators. And the first microcontroller which was discovered by Texas Instruments, and the second was from the Intel itself. Now as you see the evolution of the IC technology, the 8080 IC were integrated with the clock speed of 2 MHz and it has a data width of 8 bits. Now later on when the IC technology increase, your clock speed will also increase, and that too with the data width. Now we currently have a data width of 64 bits buses as a whole. Now moving into the applications of microprocessor and microcontrollers. Microprocessor, as I said, it is performed or it is integrated to do general purpose task, and therefore and also for the microcontroller it is integrated to perform specific task. Now microprocessors can be seen in desktops, PCs, laptops, workstations and supercomputers, etc., and they can be found in 32-bit and plus for a 62-bit machine. Now microcontrollers are used in toys, cameras, washing machine, television, refrigeration, music system, etc., where it needs to perform specific task. Now moving into the fabrication or production of a application based microcontroller system, we have it divided into three sections. One is the hardware section, software section, and then the compiler part or the programming tool. Now the hardware section is nothing but the understanding of the pin diagram and interfacing the controller with the real world. And moving into the software design is nothing but the language or the code development in which the microcontroller is being written. Now there are three types of languages in which microcontroller can be implemented. The first one is the machine language, and then comes the assembly language, and then the high level language. Machine language is nothing but the language which is understood by the machine itself, and it is zeros and ones. Now assembly language is nothing but the language written in mnemonics or hexa code. Now the high level language is nothing but which is written in C, C++, Java, Python, etc. And you need a compiler to compile this high level language to be understood by the machine. So this high level language is then converted into machine level language with the help of a compiler. Now moving into the disadvantages of using an assembly language is that it doesn't get portable to other controllers. So the code which is written in an assembly language in a specific controller cannot be ported to another controller. Now moving into the disadvantage of using a high level language is that the size or the hexa file which is being created from the C file is of larger size. So if I use a larger program, the hexa will be created in a much larger size, and therefore it will be using a lot of RAM memory. Now moving into how a microcontroller programming is done. Now this microcontroller code is written in an integrated development environment and with the help of a programming language like C, C++ or even assembly language. Now the code which is being written is then converted with the help of a compiler into a hexa code. And this hexa code is then transferred into the microcontroller for the compilation and the running purpose, debugging purposes. And that is all about the introduction of microcontrollers. Thank you.